Welcome to International Innovations. This will be a two-part conversation on the topic of biofuels. Biofuels are a type of renewable energy source that are produced from organic materials such as plants and microorganisms. Biofuels have an incredible potential to reduce our dependence on fossil fuels and yield environmental and economic benefits. Joining today on Innovations are guests Sylvain Verdier, Senior Business Strategy Manager of Strategy and Innovation at Topsoe, Surajit Mukherjee, Lining Subject Matter Expert, and Bob Bernard, Engineering and Specifications. Both Surajit and Bob work with AkzoNobel International. Sylvain, Surajit, Bob, welcome to Innovations Vodcast. Sylvain, before we get started, if you could provide a background on yourself, if you could explain to the viewers, your professional background, especially related to biofuels.
Yes, of course. First of all, thanks for having me here today. It's a pleasure to be here and spend time with you to educate a bit people on what's happening out there on the biofuels. So my name is Sylvain Verdier. I've been working 17 years in a Danish technology and catalyst company called Topsoe. I'm based in Denmark, and I'm a subject matter expert in renewable fuels. And what do we mean by that? It's renewable diesel, sustainable aviation fuel, these kind of fuels. So that's what I do.
Okay, thank you very much. And Surajit.
Hello, everyone. I'm Surajit Mukherjee, based out of Houston, Texas. I'm a tank lining and a corrosion and insulation SME. What I've done so far is basically lab work. I'm a chemist by profession. I formulate. Past 8 years, I've been actively selling into the biofuels, SAF market for feedstock onto the finished product. Faced a lot of challenges and would love to talk about these topics here today and educate, learn myself. In all, this is my year 26 with AkzoNobel and 29 in the coating industry.
Perfect. And Bob Bernard.
Thank you.
Yeah, thanks, Jim. Appreciate having me. I'm Bob Bernard with International Paint. Like Sylvain, I've been with the company 17 years. I work as an engineering solutions representative. Collaborate with owners, engineers, and technology providers to recommend fit-for-purpose solutions for their biggest corrosion challenges. Most recently, Suraj and I presented at a Materials Technology Institute conference on biofuels, focusing on linings. And I've been immersed in the renewable fuels market now for about the past 2 to 3 years with a focus on feedstock storage. So, yeah, very excited to be here with this group. So, thank you.
Well, I'm very excited to have the three of you. And if viewers, if you haven't figured out, we're going to be talking about biofuels. And the purpose of this vodcast is to educate, enlighten, and inform. And the first thing I want to throw out, we're going to have an open discussion on many different topics related to this fascinating topic of biofuels. The traditional oil and gas industry is moving so fast from a situation of, one feedstock source, which is crude oil. And you have these different feedstocks that are now coming in, and they're all very different. They have lots of different risks to them. And a lot of the industry is still kind of learning how these feedstocks really interact, how they can cause highly corrosive environments, and also to work against some of the process equipment, storage, and things like that. When we're looking at feedstocks, and feel free, anyone can jump in on this, what are some of the, physical, chemical processes and properties of the feedstocks, biological sources that really kind of represent a threat to the biofuels sector?
We'll start with, right now, the biofuel productions worldwide is around 3 million barrels per day. And what is it composed of? So it's about 2/3 ethanol. So in the US, it's corn ethanol, which is quite big. Then maybe you have 30% FAME or biodiesel, which is made in the US, for example, from soybean oil. And then 10% is a mix of HVO or renewable diesel and SAF, sustainable aviation fuel. But it's maybe, of this 10%, it's maybe 9% renewable diesel and 1% SAF, sustainable aviation fuel. So this is, the status. And about 90% of all these biofuels are made from crops, feed and food crops. So for ethanol, it's corn, ethanol, sugarcane in Brazil. And then for the FAME, biodiesel, it's a lot of edible oils. So palm oil, not in the US, but in maybe some parts of Asia, soybean oil, rapeseed oil in Europe. So it's a lot of this, nice oils. So in terms of corrosion, and here my partner in crime today can elaborate, but the acid number, for example, something we look at, it's below 5. So it's very low acid number. And then about 10% of these biofuels, especially in Europe, are made from waste. So used cooking oil, animal fat, crude tall oil, which is very acidic, palm oil, and this here we talk about acid number of up to 200. So, but it's a minority, but this will grow. So basically, that is what is done.
Sylvain, in USA, we see a lot of tallow. We did start with the plant-based source, corn, soy, I would say 8 years ago. But if I talk the last 4 years, a bit more, we're seeing a lot of tallow. As you know, tallow has got a very different kind of chemistry, carbon chains, the acidity, whether you call as a TAN number, which is a total acid number, or you call free fatty acid content. We're seeing those materials being more and more out there, and the difficulty is the tank manager or the site manager have no clue what's going to go in what tank. So for a few weeks, you may have corn oil in a tank, which is a totally different game altogether. And next month, he's got tallow on the same tank. So he is juggling with what solutions to have here on these feedstock tanks that will serve both purposes. And as you know, the temperature is very critical also here, because the veg or the plant-based source, you could get a nice flow material at 40 degrees C or 104F, or at 50 degrees C or 120F. It's beautiful. You can pump in, pump out. But when it comes to tallow, you may have to hit up to 140, which is 60 C, or 65, which is 160F. Some even go higher, up to 80 degrees, which is 178F. So you may have to go up and down that temperature, and as hotter this material is, the more aggressive it is, as these acid molecules are more permeable into any coating system. So there are a lot of challenges out there. Bob, any comments from you on this, mate?
Yeah, I think you guys have made some excellent points. The acid number that Sylvain mentioned is very important. He mentioned numbers as low as less than 5, which is very manageable, but can range up to as high as 200. So that range between 5 to 200 is quite high. And then you throw in the temperature that you mentioned, and you're right, you have operating day-to-day temperature, which is something that we often get, but there's these spikes in temperatures from loading and offloading and having to move that feedstock through the system. So these are all questions that we have to fully understand when we make a fit for purpose recommendation to these owners. And so it's important that we get information from folks like Topsoe to understand what these feedstock processes look like. The different types of processes as far as the raw feedstock tanks, when they treat those feedstocks to be able to go into the processes. It's a whole bunch of questions that we fully are still trying to understand. And then he mentioned, you've got food source based feedstocks, which can be, very manageable to now wastes and coming into the picture. So it's a matter of, am I using one type of feedstock, or like you mentioned, Surajit, are we going to blend those feedstocks and use multiple different solutions? So there's a lot to be understood. The conversations that we have to have are very in depth, and sometimes it's just not a one conversation and we have our answer. It's take some information, look through it, come back, have more conversation, and fully understand so we can provide a good solution for the long term here. So it's it's still, even though the industry has been doing this for a little while, it's still fairly new, and I think we're all still learning. So yeah, this is I think a very great topic to be having with the folks out there in the industry today.
Yeah. And Bob, let me expand on the learning part of this. Traditional industry, when we're looking at fossil fuel based feedstocks, crude oil, let's call it that, you have corrosion mechanisms that most of the industry currently today has a thorough understanding of what's out there. When we're looking at renewable feedstocks, what corrosion mechanisms are encountered and what can be the effect of these new corrosion mechanisms?
Sure. Let me start off with talking about the challenge here. So when you talk about fossil fuel based material, or let's say simple crude oil, crude from Malaysia, crude from Saudi Arabia, crude from Canada, they're still crude. And sitting in a tank in a year, 2 year, the properties is going to change a little bit, but not a lot. It's still 95% plus the same stuff. Let's come to this material. When you have a animal-based or a plant-based feedstock here, and you leave it on for 6 months and you come back to it, your tan number would double or at some time triple. Okay, what's happening is there is a process reaction happening in that tank in situ, as I call it, a living organism or living thing, where you have a reversible reaction happening with any of the free fatty acids and esterified materials in there going back and fro in presence of moisture because of condensation that's going to get, temperature that it's going to see, and your tan number or the total acid number is going to go high. So that is a real challenge for everyone to understand that this is not fossil fuel. This material is live. This material, if it sits there for 3 months, 6 months untouched, it is going to increase in acidity, what we call rancidity, because it's going to have a smell that you get because of a reaction that's going to go with temperature, the oxygen or the air, and the condensation water is going to get. So it is going to get more and more aggressive. Okay, so that's the first part. The second part I want to talk about is when you look at MIC kind of scenarios, and then we can look into the solution afterward. Let's just put the challenge in front of us first. The double bonds in these carbon chains, they love to attack steel. And I'm talking about unlined assets here, especially the welds. And over a period of time, could take 5 years, 10 years, they will gradually start eating these weld areas. Okay, because the double bonds, they love certain things. And I'm talking about unlined assets. Of course, if you got a CRA, which is a corrosion resistance alloy, you're great. But we all know how much that costs. So majority of the operators, whether for an OPEX or a CAPEX scenario, they prefer to go for a carbon steel vessel, which they would line. So I just listed a couple of challenges that is very, I hope, easy to understand rather than delving into a lot more detailed chemistry. There's a lot more things out there we can outline and talk about. Bob, am I missing anything here, mate?
No, I think you hit the nail on the head. And one of the key things you mentioned was unlined assets. So in a refinery, a typical refinery holding crude oil, we would put a tank lining recommendation in the bottom of the tank and up the wall, maybe 3 feet, 1 meter. And that's because when you put the crude oil in, the water separates out to the bottom, and that's where you have your most issues with corrosion. But now when you're starting to hold these other feedstocks, like Sylvain was mentioning and Surajit was mentioning, that are more plant-based, bio-based, waste fuels, we have to protect the entire tank. So a lot of the times our recommendations are to put a lining on the entire tank internals, including the weld seams, obviously, and then the roof and rafters, because we just don't know some of the unpredictability of where this corrosion is going to take place and where some of these issues might happen in a tank for corrosion attack. And so we always typically recommended to line as much of the tank as possible. And sometimes that's part of that discussion and education to the owner is you're not used to lining all of your tank assets in unlined areas, but it's a discussion that needs to happen. So that way we're, protecting for future corrosion challenges.
So corrosion is actually also affecting our part of the supply chain, where we are actually. It's like Lego bricks. So we have the tanks with the feedstocks, then it's coming to the hydroprocessing unit. This is where we are. So basically, imagine you have a diesel hydrotreater and you want to co-process, I don't know, 5% used cooking oil, 5% tallow. So what happens? So here we see 3 types of corrosion, and my colleagues who are mechanical engineers would roll their eye to listen to me talk about that, but I will try my best. So number 1 is acidic corrosion. So all the acid number we talked about, and this is due to free fatty acid. So yeah, the more it's a waste, the higher the acid number normally. So here, yeah, what is the acid number? 5, 10? Do you need to do some lining at the beginning of the reactor or not? And here these feedstock are very reactive, so the acid number will quickly decrease as soon as it reacts over the catalyst. But then what happens when it reacts? So all these feedstocks contain around 11-12% oxygen, and this oxygen will either become water, which is what you want, or become CO2. And the CO2 will make carbonic acid corrosion. So here, different types of corrosion for different parts. And say you work with used cooking oil, you have a lot of chloride, and here you will have chloride-induced corrosion. So also different parts, salt formation and corrosion. So different types of corrosion, different solutions, and it would take more than 10 minutes to discuss that, but these are the issues we are looking at in terms of corrosion, specifically when you process such lipidic feedstocks.
And Sylvain, you made a good point about the catalyst, and we've heard that depending on the types of feedstocks that are used and how well those raw feedstocks can be cleaned and purified before they come into your, renewable diesel unit, that could impact the life of the catalyst. And so the goal is to clean that feedstock as much as possible and get it as pure as possible, so that way your catalyst can last as long as intended. Is that correct too, as part of that process?
Yes, it's correct. And this is critical. So it's because between the tanks where you are and the 100% unit, you often have these pre-treatment units. So here you have companies like, I don't know, I will name a few, so no one will be jealous, but it's Alfa Laval, Crown Iron Works, Desmet Balestra, ARA Technology, and so forth. And here the idea is to clean. It is well-known technology for the biodiesel producers. So it's how do I remove chlorine? How do I remove phosphorus? How do I remove, let's say, you have sometimes some plastic around the animal fat tallow, and these polyolefins might also plug the unit. So how do I remove that? And here it's also, again, like Lego, they have different steps, degumming, bleaching, and so forth. And here the idea is to have a feedstock as clean as possible, but there's also a cost, and you lose some yield, 5% maybe of your feedstock through these steps. So here's the idea is to play with this. So, and you also have some steps where you can actually deacidify the feedstock. So it's maybe you would not need to reline the top of your reactor if you do that.
Yeah, and that's an important piece when we come into the conversation, because we need to understand the tanks, if they're the raw feedstock tanks, or if they're part of the pre-treatment. And the product purity is an important piece of that. And so that's why a lot of times we recommend lining an entire tank, because we don't need any corrosion particles to be, coming in and contaminating the cargo. Similar to like drinking water, you would line an entire drinking water tank because you don't need any corrosion products contaminating the water. So it's important to understand for us what's in that tank and how important that purity is of that cargo and product before it's moved to the next part of the process. And so, we're all part of that chain, whether we're upstream of your process or downstream, because at the end we're storing, the finished product, and technically, we have to make sure those tanks are also, protected. But yeah, we all play an important role in this process. So yeah, thank you for sharing that.
Thank you for watching part 1 of 2 on the topic of biofuels. If you'd like to get additional information on AkzoNobel International products and solutions, just go to international-pc.com.